Good morning, Madam CT. We are presenting our mathematics AMOA project on the topic trigonometry, which is done by my group members, which is myself, Senthil, Nigel Eng, Brian Low, and Marcus.
Okay, in task 1, we'll be exploring exactly what trigonometry is and what the Pythagoras theorem and trigonomic ratios refer to. Firstly, what is trigonometry? Webster defines trigonometry as the study of properties of triangles and trigonomic functions and their properties. Using definitions of trigonomic functions of angles, one can find relationships between sides and the angles and sides of the triangles. Trigonometry is widely used in engineering, applied in science and navigation. Firstly, then we go to what is the Pythagoras theorem. It's a simple theory which is saying that a square plus b square equals to c square, where c is the hypotenuse in a right angled triangle. So, next, what are trigonomic ratios? Firstly, we have three of the most important trigonomic ratios: cosine, sine, and tangent. The Tuakaso basically. Sine theta refers to the opposite over the hypotenuse, which is y over r. Cosine theta equals to adjacent over hypotenuse, and tangent theta equals to opposite over adjacent. Next, task 2.
Okay, in this task, we will explore how trigonometry can be used in everyday situations to solve problems. One such example is a case that happened in Albany in 2002. Okay, this is the link. Thanks to the amazing Pythagoras theorem, the judges were able to prosecute James Robbins with a much heavier sentence. Thanks to the wonders of the Pythagoras theorem, James' lawyers initially argued that James did not sell drugs within 1,000 feet of a school. However, the Pythagoras theorem proved otherwise. Law enforcement officials calculated the straight line distance using Pythagoras theorem. A square plus b square equals c square, measuring the distance up 8th Avenue, 764 feet, as one side of a right angle, and the distance to the church along 43rd Street, 490 feet, as another, to find the length of the hypotenuse, which was 907.63 feet. James Robbins is currently serving a 6 to 12 year sentence.
This is the sketch of the scene. As you can see, 8th Avenue is one side and the line from 8th Avenue to 43rd Avenue is the hypotenuse. The school to 43rd Street is 490 feet. 8th Avenue to Holy Cross is 674 feet. And using this, we can calculate the hypotenuse. And we can figure out that the feet is less than 1,000 from the school. The right angle, yes.
So, what do you learn? Don't do drugs.
Trigonometry can also help us to find out the distance between rivers. What a waste of time, just measure it yourselves, skeptical maths haters might say. But sometimes the real world gives us a river that is too difficult to cross or a cliff too dangerous to climb. In such cases, the physical approach isn't possible. Thus, we need to use trigonometry, a mathematical technique that we can trust for the answers we need. Well, how then do we apply trigonometry to such cases? Okay, first let us refer to this simple diagram of a river. The river, we can see that we can draw a triangle in the middle of the river where the adjacent side will be 400 meters and the angle will be 31 degrees. Thus, we first set up a survey post directly across the river from some landmark, like a tree. Then we head downstream a distance that we can measure, in this case which was 400, which is the adjacent. That's the red horizontal line in the drawing. Now, we take a sighting on the tree from downstream. That's the black line in the drawing. The surveying instruments will thus tell us what our sighting angle is. In this case, it is 31 degrees. We know from the previous page that the tangent of 31 degrees is equal to the length of the blue line divided by the length of the red line, which is 400 meters. which is given by trigo ratios. So if we multiply the tangent of 31 degrees by 400 meters, we will get the distance across the river. The tangent of 31 degrees is about 0.60. That means that the distance across the river is 0.6 times 400 meters, or 240 meters.
In this task, we will be exploring to the solutions in the task tree entitled Janitor's Helper.
Okay, first we will find out the shortest distance from the rubbish dump to bin A. So we will name the shortest distance to be C. Thus, using Pythagoras theorem, we can find out that C squared is equal to 15 squared plus 20 squared, which is given by the Pythagoras theorem formula with A squared plus B squared equal to C squared. Thus, we come to the deduction that C squared is 625. Thus, C will be 25 cm. Thus, the shortest distance from the rubbish dump to bin A will be 30 plus 2 times 25, which is 80.
Okay, now this is question 2. The question asks, they should put okay, there's a starting flagpole. They should put another flagpole. I don't know why, which is the same height, so they can have 2 flags, okay? Okay, to find that and the guy is kind of stupid, he doesn't know what's the length of the flagpole, so he used Tuakaso. The solution for this problem, he can measure the length of everything except the pole. He's stupid. The solution tangent 37 equals to the opposite over adjacent, where we know what's the adjacent, which is 100, but the opposite is don't know. So 100 tangent 37, if you press on your calculator, it will be 75.6 cm. 3 significant figures.
Okay, now that the pole is up, it won't stand against the wind. So we're finding a way.
Again, he's stupid.
The angle between the cable and the pole is 25 degrees. We're finding a way that we can use support cables to help to hold the pole up, basically. Well, in order to find how far away the pole should be from the anchor, we use the TWA method, basically, meaning that tangent theta will equals the opposite of the adjacent. In this case, we know that the angle is 35 degrees and the adjacent is 75.37. So we use that and we manipulate this equation to give us the opposite with all the tangent and all that. So from this we can find out that the anchor should be 35.1 cm away from the flagpole. 3 significant figures.
For our last job as a janitor, we had to fly a very large balloon above the school to welcome the new freshmen. We are supposed to support it with 3 strings, each one attached to a side of the building and one in the center. So we need to find out how long should the center string be to allow the balloon to reach its maximum height. So to solve this, we use the cosine rule, which is cosine theta equals to adjacent over hypotenuse. Since we know that the angle is there's no angle. So the solution is cosine 80.6 times 50 equals to 8.173 SF. Exactly.
We have come to the end of our presentation. Thank you for your attention and hope you have enjoyed it too.
Thank you.
Thank you.
See.